What it's about is a lot about how languages are formed and a lot of how we can represent languages in different ways and how different languages are classified, as well as how we can build machines to essentially accept or deny these languages.
The course, I would say, is about logic and how a lot of the systems that we have, computer systems and just logic in general, how they work and why they work.
I'm really fascinated by the automata and the Turing machines. These simple machines that are capable of calculating anything that can be calculated by definition. But these are the definition of what it means to compute. Well, this definitely builds on, I think, algorithms somewhat and discrete mathematics a tremendous amount. It talks a lot about set theory and mathematical logic, which you cover some of in discrete mathematics.
This class kind of takes it back to the sub-level of what all computer science is founded on. It's really all of the how systems work together logically. So how one thing relates to another and why the different categories of how it relates to that thing. It's all very powerful stuff, but it's very broad too. So I think that honestly all of the CS classes that you start with kind of work in the real functional doable things, but this is very broad and expansive and covers the logic of why everything else that sits on top of it works.
So theory of computation I don't think is a clear prerequisite for some subsequent course. It's kind of a terminal course in and of itself. I think that it will prepare me well for grad work if I'm interested in researching, the limits of computability and decidability and other kind of theoretical concepts. And I think that in general, the concepts that we talk about, like state machines and the complexity of different kinds of problems, so permeates the entire field that in a way, I don't know that it will have prepared me for one singular task so much it will have changed the way that we think about the relationship between different systems.
I would usually put 3 to 4 hours into it. I would say it's probably not enough. A lot of this stuff kind of clicked with me, and then when I'd get home and start dealing with the homework itself, I'd have to really sit down and think about it. In that regards, I would say, yeah, I probably should have studied a bit more, but at the same time, it sat with me. Learning the content itself kind of stuck with me really well. It's a very tough class, by far probably the second hardest class I've taken.
Dr. Homer does a very good job of trying to make sure that he's accessible to students so they can help them through the work, and he really enjoys explaining the concept if we didn't get them in class. So if you're struggling with the homework, make a point of completing it sufficiently ahead of time that either you can solicit the help of other students in the class, which Dr. Homer is okay with, for the purpose of working through the problem, or that you can stop by his office and specifically ask for help, because he's usually more than happy to help you. This is actually a lesson I learned back in his algorithms class, completing your work ahead of time and then specifically asking him for help. It's really important. So being very attentive to every assignment and making sure that you've completed it fully and that you've validated that it's correct with either with the teacher himself or with your other student.
But just stop and ask questions, figure out the answers to why things don't work, and get a feel before you move on, because everything builds on itself and it builds on the thing before it. So you need to have an understanding of the things that you have already learned in class to understand things that you're covering now.